Fine. So now let me introduce you to our next speaker. So this will be Mohit from Thomson Reuters Lab. So in brief, Mohit is currently a manager of applied AI research at Thomson Reuters Labs, and he has over 9 years experience in machine learning, deep learning, and NLP. And his original background is a master's in quantitative economics from the ISI. And prior to Thomson Reuters, he has worked in several other firms also, like the MSCI and the American Express. And Mohit will be talking about something which we have already heard about, that is large language models. And the title of the talk is Legal Prompt Engineering for Multilingual Legal Judgment Prediction. So legal judgment prediction is one of the respected tasks in legal NLP, and it will be great to see how they have done prompt engineering for this very challenging and practical application. And just the last thought is, the last thing to say is, we thank Thomson Reuters for being the diamond sponsors of the event. So Mohit and all the others from Thomson Reuters who are here, so really a great thank you for the support. So Mohit, over to you.
Hi everyone. I'm Mohit this side. Okay, let's start. So I'll be covering legal prompt engineering for multilingual legal judgment prediction today. The presentation will be broken down into two parts. First, I'll just give you a quick overview of Thomson Reuters, who we are, what we do, and then dive deeper into the topic of legal prompt engineering and what we are doing with it. Okay, so as the slide mentions, Thomson Reuters is a leading business provider of information services. It provides information-enabled software tools for legal, tax, and accounting, and compliance professionals. And also we have the global news service, which is Reuters. What this slide basically covers is what our business is more around. So on the left side, you see the revenue distribution, which kind of tells you the segments we operate in. The first one, primarily the largest one, is legal professionals. We cater to legal professionals across multiple geographies. We have corporates, tax and accounting professionals, Reuters News, and global print. As the slide mentions, we are the number one position in global legal market segment. We are a market leader. 99% of AmLaw 100 firms used our online information products, and we have a 90% annual retention across legal professions and products, and all of global 100 firms are Thomson Reuters customers. What this slide does is it kind of gives you an broad overview of Westlaw, which is one of our primary products. It's present in US, Canada, Australia, multiple countries. It's good for authoritative, it kind of offers legal research. It's a legal research platform. It delivers authoritative content, very powerful search functionality, and navigation tools to help legal professionals do their task. Now, what I'm sharing on this slide is one more product, one more feature on Westlaw, which is Westlaw Quick Check. I think this kind of resonates with a lot of stuff that people discussed here before me, right? So this is a software that enables legal professionals to do a lot of things, which involve around, which are mostly around intelligent document analysis. So, for example, if you want to check your work, if you have a brief or an early draft of your work, you can upload it and check it, and it kind of points out potential flaws or areas of improvement within your document. So it kind of helps legal professionals improve their documents, which they use in quotes. At the same time, there are features like analyzing opponents' work, which is basically doing the same thing but on your opponent's brief. So if you have your brief, it can analyze it for you. If you have your opponent's brief, it can analyze it for you as well. It can kind of point out things that are missing and contrary positions that you can take. And then there is quick check judicial, which is kind of completing the requirement for judges as well. So if somebody wants to analyze cases from submissions from both the parties, they can do it using this as well. So that's broadly the kind of products we have in the legal domain. Thomson Reuters Labs, we are representing labs here today. We are the applied research division of Thomson Reuters, and we work in emerging technologies, and our stakeholders and customers, we always collaborate with them to figure out what's the best we can provide using our tools for everyone. And this kind of grid here explains the kind of work we do. Generally, the kind of work we do across products. So you have Westlaw and Practical Law. These are, again, legal tools. You have HiQ, which is contract analysis. Checkpoint is for tax and accounting professionals. And Courtwire is again legal. Right. So, and you basically what you see on the grid is the kind of use cases we have, right? We have search, question answering, NER, summarization, text classification. These are areas where we have delivered models and we kind of usually work on, and we are heavy on NLP. I'll just quickly go through this one. This is research areas, the kind of research we do at TR Labs, which is, as I mentioned, mainly NLP. Then there is human-centric AI, which involves interpretability, explainability, transparency, fairness of the models. We try to work on that. Then AI DevOps, model ops, which is the idea is to make the process of building and deploying models as smooth as possible. And then we do information retrieval and question answering. We publish papers every year. You can kind of visit our site for our publications. And our teams regularly participate in conferences, seminars, and workshops. Okay, so I'll be delving deeper into a study that was performed, and I'll heavily be borrowing work from work that was done by these folks, Dietrich, Alina, and Frank. These are our labs colleagues. And the kind of experiments the team ran using GPT and the likes. Okay, so prompting, right? So what is prompting and why do we need it, right? As many of you would know, prompting is a new paradigm in NLP. It's a way to query large language models. And these models are trained on large web text, for example, GPT. Right, prompt-based learning is based on LLMs that model the probability of the text directly. And prompts typically, and I'll show you some examples in the subsequent slides. Prompts can contain questions about the current sample, examples of input-output pairs, and task description. So basically, within a prompt, for example, while chatting with ChatGPT, you can kind of give all these pieces of information. You can provide a question that you want answered, a few samples of how it needs to be done, a description of the task, and then kind of ask it to perform the task for you. The thought process here is more around models like GPT, is that you kind of have a very large language model which is very good at general purpose things. So can you just give it very minimal data, and you don't need to fine tune, you just give it some prompts, and would it be able to generate answers for you that are relevant, right? And yeah, that's the last point, right? And we basically, legal prompt engineering is again applying prompt engineering in the legal domain, which is what we are discussing and attempting here. Okay, so this is so this is OpenAI GPT-3 Playground. I'm sure most of you will be familiar. So what this is showing, although now ChatGPT is more advanced, so most likely it might be able to do this directly, but this kind of motivates the example, motivates the process here. So for example, if I want a GPT-like model to reverse a word, what I can do is give an example, right? And that example above here is alphabet. And then I kind of give it reasoning, which looks more like a pseudocode, right? So I tell it how to kind of number them and reverse them, and ultimately get, remove the numbering and ultimately get the alphabet. And what I'm doing here essentially is telling the model that this is how you are supposed to perform this task. And then I give it a second word, encyclopedia, right? And what it goes ahead and does it is that in green, you see what the model produces, right? It just replicates my way of reasoning, and eventually arrives at the reversed word, right? And that's basically the idea. And this is, in this case, this is one-shot learning, right? So you kind of gave it one example, and it learned from that, the context within that example, and tried to do exactly what you, in a way, without training the model, taught it right there while asking a question, right? Yeah. E- Mm, Okay, so think of it like this. There can be various functions that you can write to do the same task, right? This is one way of doing it, where it's using a merge operation instead of removing spaces. But removing spaces is also a valid way of doing it, right? So it's like, yeah, you could actually come up with many, many more ways of doing this. You just teach the model, this is one way of doing it, and this is how I want it done, and it kind of learns from it. That's assuming that the model wasn't able to do it in zero shot anyway, right? Because given the progress these models have made, I'm pretty sure that you don't need to for this example. But there are other examples where I'll show that this is important. But yeah, there can be various ways of doing it. Okay, prompting. I've kind of already touched upon this. There are multiple ways of doing prompting, right? So one is few shot. So few shot, within few shot, you have few shot fine tuning and in context learning, or you have zero shot learning, right? Few shot fine tuning is basically have very few examples. You want to fine tune your model on that and see if it kind of learns the task. In context learning is basically you give the context, within that context, it's able to learn, and it can again learn within few shots. So basically, uh, and these models have usually decent amount of number of tokens that you can pass. Maybe if a model has 2000 or 4000 odd tokens and you have examples that kind of fit into that, you can basically give 7 8 examples, and those are few shots, and the model learns from those and then performs the task. uh, then there is model memory based, which is parametric in the weights, or non-parametric, like a dense retriever, which basically goes and fetches the result from elsewhere. Parametric is basically the model has things in its memory already, right? And yeah, on the right side on this slide, you see an example of few shot learning, where what we're teaching the model is basically is translate English to French. We give a few examples and then let the model translate the last example. Okay, moving on to legal prompting. Why is it different, right? So what's different about legal prompting from prompting in general? What is different is, as everybody knows here, we have unusually long documents. So it's kind of tricky to fit them into the memory of the model. I mean, the number of tokens it allows. And sometimes legal reasoning is necessary, which is harder because it's, again, we're talking about explainability. Then specific vocabulary, in fact, for a lot of models, when you, for example, legal BERT and all, that's the reason why you need legal BERT or bio BERT or models like those, is because when you, for example, use word piece tokenization, just like BERT, on corpuses which are legal, there is very little overlap that you get, right? Which kind of says that the vocabulary might not always be sufficient to do the task. And hence there's this specific vocabulary that poses a challenge. And then there is lack of domain specific large language models and lack of strong benchmarks. There are very few, in fact, and you see them appearing everywhere because we have few. So these are the challenges that we face, and these are things that we want to look at while doing legal prompting. Okay, motivation. Why are we looking at this? These are the thoughts behind the experiments around legal prompting that we're doing. One is it assists us in data annotation projects. So think of it like this: you do not have enough. This is commonly a problem, right? You do not. It's difficult to annotate data sets, find good annotated data sets. What if a model can do it for you, right? So if it annotates samples from you, and then you can kind of learn a supervised learning model on top of it, that makes the entire process easier. We also want to explore emerging technologies. That's why it's a good thing to look at. And it's AI interaction via natural language, so coding is not required. Uh, and it saves costs, and particularly in the direction of sustainable training of models. You have one joint model which somebody has, which you train once essentially, and then everybody can reuse it, right? And it can be deployed for multiple purposes. Kind of saves the cost to a huge extent if it can be a model that generalizes as well. And as I mentioned, right, solves multiple tasks with just a single model. So those are the potential benefits of this. Okay, disclaimer, what I'm showing here is a purely academic exercise. There are no plans as of now to include this in any of our products. The outcomes that you see here, because I'm not a legal expert, so the outcomes that you see here are mostly being evaluated by subject matter experts and model governance teams and others within Thomson Reuters. Okay, so what's the task that we are looking at? We are looking at legal judgment prediction here. So given a case and its facts, what is the judgment that will come out of it? The task is to predict outcome of a court case given the case facts. But yeah, there's a caveat there that judges may not always consider only the facts. They can take external information about the defendant and the court's view into account as well. So what this means is that the facts that you see are not the only thing, but a good indication for you to test out models. Okay, so the data sets being used for this project are these two academic corpora so far. ECHR, as all of has been used quite widely, and then Swiss Federal Supreme Court. Sorry. ECHR is mainly in English. You have what you get in the data are factual facts extracted from the case, and it's mapped to ECHR articles that were violated, right? So it will kind of tell you which human rights are being violated. And the training set is 9,000, validation and test is 1,000 each. Then there is Swiss Federal Supreme Court. This is a multilingual data set with 85K documents covering German, French, and Italian. And binarized judgment outcome is approved or dismissed. In fact, for ECHR as well, what we are doing is that even though the original problem is multi-label in nature, so it kind of already, the data has that these are the articles that are violated for each case, and some cases are there for which no article is violated. So we kind of converted into a binary task here. Is any article violated or not? Okay, so models that were experimented with here are typically the models that you'll go to: BERT and BERT-like models. You'll have T5 and models like of that family, and then there are GPT-based models, which are next token prediction type models. What I'm covering here today is the last one, which is GPT-based models. And primarily we relied on two models, which are the open source available models, which is GPT J6B and GPT Neo X20B. The 6B and 20B is the number of parameters, so 6 billion and 20 billion. And then the MGPT-XL is a language multilingual model. Just for comparison, this is 6 and 20 billion. I just asked GPT what are the general number of parameters across models, and you can see that somewhere larger than GPT-2, but not really at the level of GPT-3. And it also kind of, I didn't ask for it, it kind of points out that, models are constantly changing, and, more parameters definitely don't always mean better performance, right? Okay, so what are the decoding strategies that we use? So think of it like this. Although in this case, it's mostly a binary problem that we are looking at. So you have a token that is being predicted, which will be like, yes or no, basically. So you don't need to go a lot into decoding strategies. What you can do is just pick up the one with the highest probability as the first token. But the idea here is that these are the kind of strategies that people use while trying to get predictions from text generating models. So for example, greedy search is basically always, just pick the highest probability continuously. Beam search is select the best probable response. Basically, you don't always pick the top probability, but you also expand to subsequent tokens and pick the collection which is kind of highest. Then sampling techniques, which are temperature, top K, top P, which are more around basically you sample given the proportions. For example, in this diagram, what you see is that temperature 1 is basically random sampling, which basically says that given the probabilities of the words that you get, you sample with exactly that probability, right? So this kind of creates it doesn't push your model to always give out the same outcome, and it's useful for creating interesting results. And temperature is something that controls for the differences between different probabilities, right? So you kind of it can help you scale up or scale down relatively. So for example, if you set temperature at 0.5, it maximizes the gap. So if the probability is high, it will go even higher. But if it's low, it'll kind of push down lower. So there'll be more discrimination. There's also contrastive search, which is something that is new. And then there is repetition penalty, which is basically, again, trying to generate interesting results from a model, because these models tend to get a bit repetitive at times, right? So, and that's the reason behind all these random sampling and approaches like those as well, that you want more variety. Okay, so how do we create a prompt here? Essentially, right now it's a manual exercise, but there's also research going around, and how can you also use models to generate prompt, which will again be fed to models. But yeah, this is how we do it. So I'm not printing a document because these documents are pretty large. This is the most basic approach, right? You give a model to GPT and then kind of let it complete, right? Just see what it does, but typically it won't understand the task that you want. So it'll kind of, it still gives interesting stuff. It kind of continues with the document and gets creative there, but again, doesn't help that much. Then you basically refine your prompt a bit, right? So you add something like, was there a violation of any human rights articles? Now, again, the model improves in terms of giving our answers, but not that much, right? You can still do more in terms of extracting a good answer from the model, and that's how prompting usually works, right? You have to figure out a way to extract good results from the model. Then you add basically question and answer in front of both of them, right? So you question, colon, and then give the question and then answer. And green is the completion that is done by the model, to make it even more easier for the model to understand. And one critical thing here is that the reason we have to do such a lot of tuning here is because this is zero-shot learning here, right? The judgments are pretty long in text, so you cannot really fit multiple judgments into the length of the document, into the length of the, offered by the model. And hence you kind of you have just this attempt, so you kind of stuff as much learning as you can into that. So you give the question, you say give options, yes, no, it further improves. Then you also use end of text token, which is offered by these GPT models, and which basically is a way of telling the model that this is here where the text ends, right? And then you can kind of do the Q&A. Now, what are the expected responses? Naturally, what we're looking for is yes, no. So basically A is yes. And if it says B, it's no, right? If the model gives these responses, we can simply say that it was successful or unsuccessful in terms of classifying it. Now, there is also an option. Yeah, this is some experiment that the researchers on this specifically did. Is basically they flipped A and B and made A as no and B as yes, just because somebody pointed out that often a lot of sentence start from A, right? So you could be like, yeah, you spurious results. So, but yeah, nothing changed. So this was fine. The model is stable and consistent enough for this. Okay, so what the kind of responses that were seen on this was one, for example, it answers A, there has been no violations of article this, right? So what the researchers here did essentially was we basically checked with SMEs, and turns out even though the answer might be correct, sometimes there is some creativity here in terms of articles. They don't always map to exactly the correct article that was supposed to be picked. And although we didn't ask the model to do it, right? So one interesting thing is that it just elaborates itself. Even after us giving all these pieces of information that we specifically want this, it gives the answer, but also elaborates the reasoning, which may or may not be correct, right? And interestingly, we could still verify in these cases because this is originally a multi-label problem, right? So you do have the labels. Yeah, so all these models are essentially trained on the web, right? So I'm pretty confident it has seen ECHR data, right? It has seen the articles, it has seen, so within the model parameters, though that information should be there, but we are talking about 175 billion parameters, right? So it's kind of, it's there somewhere is what I think. It understands what ECHR HR is, what are human rights and stuff like that. But not necessarily for this task, right? So it's kind of retrieving it from its memory. And one thing we've seen is that it kind of makes it slightly harder to solve problems like these, because think of supervised learning. There you kind of have the labels there. The model is easily, while training, able to pick up trends, right? So if it's article 1 that is being violated, it'll group all article 1 violations and be able to spot patterns. Here it doesn't have that luxury, right? We are not telling it what articles are, what, these are the articles and these could be violated. We are doing nothing. We're just giving a prompt and asking it as if it was a legal expert. Ask it whether it's being anything, the article is any human right article is being violated or not. Yeah, I couldn't. Yeah, so the prompt is whatever. So whatever you see in, okay, uh, the prompt ends at answer colon. Everything that comes before that is a part of the prompt. What you see in green, although this slide deviates from that, ideally end of text should not be in green. So far, whatever I was showing in green was the response of the model, right? Although end of text, yeah, that's should have used some different color there. Yeah. 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 So it kind of completes it, and it has a lot of bandwidth. It can go on writing much. I'll show examples, some examples with ChatGPT as well, though, but that's not. Yeah, the challenge with ChatGPT is that we cannot as of now we cannot. It's not open source, so you'll have to see sample by sample. But this is on an overall data set. But yeah, and you can also choose the number of tokens it prints out, but it does give full answers. And sometimes it kind of also gives additional explanations, which is like everyone has the right to freely participate in a cultural life, things like that. Although again, the article may or may not be correct that it is citing. But yeah, just to clarify again, everything you see here before this point, where I leave the answer column, is part of the prompt. And whatever I covered in the previous slides was basically how are we designing a prompt so as to get better performance from this. And there are various strategies that people follow around this in order to get better responses from these models. Okay. Then there are some examples where it gets it right, but not in the language in which we wanted. We just specified that give us yes or no. Although it's an older model, now we have better versions, but yeah, so it kind of gives you in sentence, but these examples we still converted to no, right? Because it's saying that there was no violation of human rights. Yeah, but that's tricky because you still have to make it learn to answer in exactly the way you want it to. And then sometimes it also gives surprise responses. For example, it said yes, and then it's posed a question, another question, question two, what is your opinion about the incident? It's kind of, it kind of sees that there is some question answering going on. It's like reading comprehension, and it's kind of completing the test for you. Uh, I think this is mainly coming from the training data set where it has seen examples like these. Okay, so right now, so far in this project, what we have are zero shot scores. There are alternate strategies that we've been looking at. Things to be noticed, noted here are no training or fine tuning on the models has been done. You just pick up the model and score. Uh, the data sets labels are highly imbalanced, right? So one challenge here is that I think something like 90% of the cases in ECHR have a human right violation. So it's highly unbalanced, and something like 80 to 85% for the Swiss code data set as well. Right. So it's kind of so that imbalance means that you have to look more carefully. What we are reporting here are these metrics. One is majority scores, which is basically saying that your model always goes with the majority class, right? What is the performance then? Random baseline is saying that the model makes a random prediction out of both the classes. Supervised scores from literature are the ones that where you have supervised models. Folks have been training models on these data sets, and what are the what's the state of the art performance in literature, and our prompting results. Okay, so what I look at is the test set here, and yeah, a lot of numbers for the sake of completeness, but we can focus on the third column here, which is basically saying that for minority class, it's pretty bad. For majority class, it's still okay, but then again, because it's imbalanced, random class, it's bad. And yeah, these are the GPT results. So it's basically, but yeah, it's lower than, definitely much lower than supervised, but then you're just passing a few prompts without any training and, letting the model decide. So it reasons better than random or minority majority. It kind of has a reasoning ability, but not at the level which we as of now see with supervised models. Although there are things that in other projects that we work on, what we've also observed is that in prompting in general, when you give a task where the model has all that it needs to infer from within the prompt and then conclude, then it kind of already is matching or even outperforming supervised models because it has everything it needs. Here, it kind of has to remember a lot of things from its memory. And these are the results for the Swiss code. And again, it's pretty similar, right? So it does do better than random, but supervised are better. Okay, so as I mentioned, right? So what we have learned from it so far is that zero shot learning is possible to some degree for these tasks, but and yeah, there is limited explainability even though the model tries to explain itself. Uh, but and long legal documents are still a challenge. And the presented approach is not possible for few shot learning. As I mentioned, the documents are pretty large. You need a very giant model in order to fit multiple documents in one go. Then there are other extensions that we're looking at. One is chain of thought prompting. This is another thing that has been going on, which is basically breaking down your problem, right? You basically tell the model that, let's think step by step. And what that does is that the model it pushes the model to produce some reasoning. And then you append that reasoning. So you give the question, tell it to think step by step, and also give it that reasoning, and then try to get a response from the model. It is shown to be getting better responses and performance. Although again, this is still a bit tricky for us given the document size, right? You can, but still, this is something that can be explored. Yeah, then I also wanted to try how ChatGPT does with it. Again, we don't have full results on data sets. I can basically just check on a few samples and see what's going on. So, and for example, here I didn't have that end of text token. So I basically threw the question right at the top where I said that, was there a violation of human rights in the case below? Yes or no? Right? And this is the case, it continues and something like this. And the model gives a fairly elaborate answer. It says there may have been a violation of article this. And if I checked it online, that when you talk about this article, this is exactly this article of ECHR. You find exactly these articles. So it knows ECHR, and it knows human rights, as I asked earlier. So it knows where to look for, and it figures it out itself. Although the answers again don't really always match with what we get in the data set. But yeah, it kind of it makes sense, right? So it's picking stuff from the document and arguing logically that okay, these are potential places where a violation was there. Now when I gave it last time, I was like, okay, answer me in yes or no. Now I'm being more persuasive. I'm saying answer only as yes or no, right? Still, it kind of reduces the answer a bit, but it's adamant that I will reason. But this did have an impact on multiple. I saw it for 10, 15 cases. What happens is that there was a consistent decline, and for some questions, it actually answered in yes or no. But then again, it's tricky to kind of make it answer in exactly the form in which you want. Then I tried think step by step. I added that, but then again, it started thinking a lot. It kind of went into a very long argument. I couldn't paste it here, and but then again, yeah. So it's not always, and it also ended up giving up the answer first. So that's also kind of tricky. If you want to make it think step by step, it should first show the thinking process, and then you can kind of push it towards an answer. But it kind of jumped to the answer here. But yeah, it's still showing the kind of reasoning it did. Yeah, that's it. Thank you.
Thanks, Mohit, for the talk. Could you explain your prompt learning case? That basically yes, no example. What is basically your input and what is basically your output during training and inference? Yes, this one.
Okay, so what you see on the screen is my input, right? What I'm saying here is a long document. So I've not pasted the document content here because it's pretty long, right? When we pass the prompt, we pass the document, then we add this token, which indicates that there is an end of text here. This is provided, it's available in Hugging Face, right? So, and then you have a question, which we specify with colon, and then give options A or B, and then ask for an answer. This is where we leave and, send the sample in a way, yeah, ask the model to score. And what we get is the response.
Okay, so during the training phase, you also provide the answer, right?
There is no training here.
Okay, no training.
Just think of it like using GPT Playground, or although we are doing it on a large data set, so we kind of have to do it in Python with.
Okay, so just one thing. Do you also provide this kind of tokens like question or basically aid?
Yes, everything you see on the screen,
Okay.
I'm providing.
Okay. Okay, thanks.
Yeah. In that case, truncate. Think of it like this, and these documents, again, there is this thing that these are facts extracted using rules. That's how ECHR has been created. So it might not be the entire document anyway. Yeah, in fact, there was minor pre-processing here. If I remember correctly, it's basically each paragraph has some numbering given in front of it. We kind of remove those numbers, just the text, but minimal pre-processing.
So what is the upper limit of tokens?
I think this had 2048 or something like that. I don't remember the.
Okay.
It depends. It varies from model to model, right? So I think this is DaVinci. This is GPT-J 6. Yeah, I don't remember it offhand, but yeah.
Okay.
Yeah.
Okay.
Yeah.
So this is some sort of zero shot learning, right?
This is zero shot learning.
Thank you.
So just one question, I mean, regarding the results you have.
Yeah.
So you showed some results.
Just a minute. Yeah.
Yeah. So these are on, I mean, binary classification,
Yes,
whether there
on the
is.
test data set.
So there's a paper on ACL 2020, Chakidis et al.
Yeah.
Neural judgment prediction. It was on this data set, if I'm not too wrong. There was one task, binary task, whether there has been a violation or not. So have you compared your performance with any of the baselines?
Yeah, that's the highest that you see here, 0.82.
Okay.
So that is the best we could find in supervised learning for this task. And most likely is that is the one that we're talking about as well. So ECTHR, there's task A and B, which
Yeah.
is and this is A. So
A binary, yes, this is a binary one. Okay,
Yeah.
all right, thanks.
This is just like I want to know about one claim that you made. You said general prompting approaches work quite well for short and textual data. So is there some research backing this claim?
yeah, that's generally in the domain that you see that in fact, that's true for most of the models we work with. For shorter data, the even classification by itself is easier. When you look at longer text, even supervised classification becomes harder.
So it's with regard to the prompting thing, general prompting approaches, right?
Yeah,
So
I'm not. I'm pretty sure that's true, but I do not right now have some specific papers to quote
Okay,
from.
okay.
But that's true.
But if we like search a bit, then we might get.
Yeah, definitely.
Okay. Okay. And regarding these results only, so your results are highlighted, they are bold, right?
Yep.
Okay. So in the test set, it's coming, macro F1 is like second, right? That's what I see. Like the supervised one is 0.82 and this is
Yeah.
528.
Yeah.
So, okay. So like quality is being compromised, but the engineering part was easy and that's the trade-off, right?
Yeah, exactly. No cost involved in a way, right? You just download the model and score. Yeah, scoring is still there, but yeah, no training involved. If you could fine tune it, it'll go. This is like a lower bound in that case.
Okay.
Yeah.
Thanks.
Actually, I want to add a point. The data set which you have used is a LexClue papers data set, and the professor was asking about the data set that was different data set, but both are ECHR data set. That was the balanced data set the professor that was asking about, and it is the imbalanced data set. And that was from 1959 to 2003 was used for training and validation. And in this data set that you have used, it is around, I think, 2006 or more than that. So both data sets are made by ECHR, but both are different data sets. Actually, that was balanced. So performance may be differ on both data set.
Yeah, all these
These
results
performance
are on
are-
the same data set, and I'm not sure about the balance imbalance as well, because the data set itself is multi-label. So we tweaked it
Yeah,
for this task.
For binary classification, that data set is balanced. It is 7,000 points for training, and that they made that.
That is not the one we're using. Yeah.
Okay. Thank you. So.
Does TR propose to release it as a commercial product at some stage?
As of now, no. In any case, we need much higher performance from a model to release it. And at the same time, there is no, okay, so if we were to release something, we would also want to have the model be more aware of legal language as such, right? Because this is a generalist model. So there's a huge scope of improvement in terms of things that can be done here. So definitely not releasing at this performance. Yeah, so it will take a lot more to kind of release something, and we're very mindful of the downstream impact as well, right? You do not want to release a model which is like 52% there, right? So no.
Yeah, so my question was more in relation to goal alignment. So as there's more sophistication in goal alignment techniques. Do you think prompt engineering would play how important of a role would prompt engineering play in that regard? So for instance, if we have like a separate bot for individual tasks that are aligned to, let's say one for classification, the other for generation. In that case, do you think, from a consumer point of view, do you think prompt engineering would be something significant?
You're saying you have a large model which is at the center, and then there are different tasks, right? In order to do that, again, these models will keep getting better with time, right? So you might need minimal fine tuning for different tasks, or if it works. So basically the way it will happen is that you can evaluate zero shot or a few shot learning, or you can do minimal fine tuning and see what works best. Ideally, what would happen with these models is that your baseline performance has gone up significantly, right? So you kind of already have a very good starting point. You can still check with supervised models. You can have the older way of doing things where you have separate supervised models doing doing the tasks. But yeah, what we've seen here is a significant gain with ChatGPT like models. So most likely what will happen going forward is that you'll have better models, better decoder based models, which kind of are generalists, and then smaller integrations or fine tunings for downstream tasks.
All right, and a slightly underrated question. So now large language models, specifically in ChatGPT, what people have been trying is to make it simulate something. So, for instance, Reddit users try to make it simulate another particular AI that is not, bound by ChatGPT's, OpenAI's guidelines and those things. So, do you think training large language models from the perspective of making it simulate something or someone, do you think that will provide better results than try to giving it examples as such? And then
I think the way that's happening is that particularly ChatGPT also has an element of reinforcement learning where there is a deliberate focus to make the model more ethical and sticking to guidelines and behave normally. What people are playing around with is that, can we make it break the rules, right? I think that's more of a fun thing that they're trying out, but in terms of improvement to its performance, it's not directly leading to an improvement. The models are trained on internet data essentially. So till the time it's not learning on the fly, right? It's not as if you send a prompt and that will impact the model's performance. It's when they train a fresh model, then they account for information and they do a lot of pre-processing and cleaning in order to train a model. So those things are minor. They would not play a role.
thank you.
So regarding the model testing, like using few shot, like prompt based, have you ever tried that K parameter, like number of samples, like maximizes? Sometimes the curve can go like an elbow. Like if you give more samples, it may predict wrong. So that K value for few shot, have you ever tried testing?
Yeah, so in different research, colleagues in labs have tried it out, right? So it kind of at times happens. So we've also observed this, but not in this particular case, because here we could fit only one sample, right? So this is one shot learning essentially.
Okay.
Actually zero shot learning, right?
Okay.
This is zero shot, few shot. In other projects, yes, we've seen that, not here, not tested here.
Okay, thank you.
Other question? Okay, so I had just one maybe last question. So you touched upon this point, no, not in detail, that I mean, one potential application of these models is to do annotations automatically. So that is a problem which we face every week, because we have to go to law students to get things annotated and they don't have time. So have you actually done some experiments in that line? No?
Not yet.
Okay.
In fact, the constraint here is also we'll probably have to get a better model for that, right? So this is the open source version, although they are also improving. We've not done those experiments yet, but they look promising, right? Definitely.
Yeah, and that's a practical problem which we face every day.
And it kind of, so you don't have to, in a way, even if you want supervised models, that helps, right? So you don't have to train a giant model. It will kind of give you some annotated data, and it's the same problem everywhere, right? So we also have to kind of, editors and lawyers who are busy with their work, we have to typically ask them to annotate some data for us so that we can do all this stuff. If that works, it will be great, but no results so far there.
Okay. Okay, so thanks Mohit for this wonderful talk.